BARC is kind of a tongue-in-cheek acronym, actually, that I just randomly came up with as I was trying to think of an idea for this presentation. And it's generally about, it's going to be all about Node.js. And talking about some virtual DOM, some WebSockets, some promises. And I'm going to describe myself first. I'm Nick Matantsev. I'm on GitHub and Twitter as @onframework. And I work as a product technical lead at MyPlanet. So basically, I get to do a bit of everything, front and back end, server automation. In the past, I used to did a bunch of work for TMX, a bunch of projects for health and pharma industry. There was a large social site that also was an interesting kind of subject matter. So, and on the side, so at work, I deal primarily with Angular. Actually, it's PHP converting to Hack, and a bunch of shell scripts, Ruby. There's quite a few languages, actually. And on the side, I've played around with 3D graphics, OpenGL. These days, I'm trying to publish some Android code. So also kind of a varied assortment of things. And in general, what kind of drives me is UX, trying to apply startup mentality to enterprise, so it's kind of this lean enterprise, and importantly, empathy-driven engineering, which is there's a huge overlap with DevOps, today I'm going to be talking primarily about prototyping and quick hacks. So normally, most of the conversation is about production. And trying to scale things, trying to make things work. But today we're going to have fun, right? So I grew up around a bunch of engineers. My dad did engineering, my mom did programming, so I had no choice but to get into this industry. I learned assembly at a very early age. And there's always that curiosity that you basically absorb, which is kind of how do things tick, what makes them work. And of course, then you say, well, I bet I could recreate it myself. I could build it, right? And so then building on top of that, it's fun to play with tech. It's fun to kind of, explore things. But it's also interesting to combine that and build some value. And that to me is startups, right? It's combining technology with some sales marketing, which is essentially evangelism, and you end up with some kind of value, hopefully, or a new Tinder. So the overall thing here is you kind of get the sense of purpose, right? And empathy is a big part of it for me, because to know what to build for people, you have to know how they think, what they expect. So, and in general, so today we're going to again talk about prototyping. It's all of these things. They start with a prototype. Right, and these last 2 years are just an amazing time to play with technology. It's just so easy to get started and do things. So, in particular, in the last couple of years, I've been really interested in Node.js, and I've been hacking a few things together there. As a result, I kind of ended up, building up a few modules, and some of which I will cover today. So, Node.js. I actually am curious, by show of hands, who has played with it at any point? Okay, that's good. Some good coverage here. So we all know it's good old JavaScript, just on command line. We know that by now there's a healthy ecosystem. There's a few thousand useful packages and a lot more thousand not so useful packages. And they all, the main thing that they all do from a prototyping perspective is they really allow you to integrate with Slack, with GitHub, Twilio, a bunch of hardware stuff, Tessel, which it's actually kind of like a Raspberry Pi or Arduino that just runs Node.js, Raspberry Pi. So that means it's really good for that initial step of playing with things, because usually what that is connecting different APIs together. And of course, not to say that there aren't excellent alternatives, and I say alternatives as in things like Python predate Node.js. So I think Node.js started out by an ex-Python committer. So yeah, but today we're just going to be talking JavaScript. So, and a brief note about why a lot of these things, they don't really work in the browser is because browsers are not trusted, and a lot of time you need that shared persistence, so you need a central party to keep a database and keep score of things. And it's just easier to start out as a command line run for a hack. So, and a typical, well, sometimes you can just get by with command line, but a lot of the time what you want to do is you still want to interact with the browser. You want to put something out there in front of the user. It's just a really good tool, really. So you can grab webcam images, you can show stuff, that's obvious. There's some WebGL things that you can present. And of course then, if you are deploying on something like Heroku to actually share the URL with people, like in the previous talk, then you still want to display something on the browser. Now at the same time, you still, let's say if you're playing with local hardware, you still want that server-side component. So really, the web browser for us is essentially a convenient interface output device. So, and generally speaking, if I go fire up Node.js and I start, trying to add some web page to it, I need to do a bunch of things. So I need to get Express going, right? I need to define all these routes to serve the UI to the browser. So it's going to be a bunch of HTML, it's going to be a bunch of CSS, and my actual client-side JavaScript. Then I have to, if the actual front end is going to be interacting back with my Node.js code, it needs to do some Ajax posts or something at the easiest, at the simplest. So, so we need to grab some jQuery for the front end to help with that. We need to think about how we serialize, deserialize things as these form fields. And of course, then laying out the UI, we need to pull in Bootstrap probably. We still need to do some, some kind of grid layout or something. So, I mean, it's kind of unwieldy because really at first, especially, really what you want to do is just show some text, show a button or something. All of this stuff is meant for production websites, right? And there's lots of boilerplate, and it's hard to modify as you kind of keep playing with it. So because it's for websites, there's stuff that we don't really need, such as worrying about security, worrying about scalability, responsive stuff, and that's what Bootstrap provides. So really, I just want a quick hack, right? So the general sticking points, as we're trying to show things from Node onto the browser screen, there's a few. So there's the interaction between the server and the client. And again, traditionally Ajax is used for that, just doing submits, form submits. It's a little over-engineered for our case. We really, all we want to do is just call a function from the client on the server. Then the user interface itself, we want to define it and we want to show it. But I don't know about you, I personally have dealt so much with CSS that by now I really don't want to even think about it. And yet, here we go, having to do position, absolute, float left, all of this, right? And now, if we have a changing user interface, we want to use some of these cool new things, like with the reactive rendering techniques, either from React or from Angular or from some of the other frameworks. And for the most part, we are OK with the absolute position layout. Like, we don't need a standard web page thing with the flowing text. So the other interesting little thing that doesn't always come up, it's the client-side routing. So that's actually not that well solved even for production websites, I find personally. But basically, it's it's that hash location, so so that you change pages without actually reloading the page. It's useful sometimes, so if we'll have time, we'll cover it. So let's talk about server-client. So right off the bat, here's a radical proposition, RPC, right? So RPC is remote procedure calls, and it actually does not come up a lot in the web world. Why? Because it's not RESTful. So RESTful is great. RPC is kind of, strange, unfriendly. It has roots in the enterprisey SOA, whatever acronyms, and SOAP being, I think, an example, and everybody knows how great SOAP is. So there's some baggage associated with it, and it's definitely not useful for everything, but for us, it's actually not so bad. It's just, it's basically a way to transparently call our functions across the network and pass values back. So at that stage, we don't even need to think about HTTP as a transport protocol because we just have these calls. In fact, then we can get into two-way communication to have that server push. So some people look at it as pub sub, some people look at it as just event notification. But again, with RPC, there's a clearer pathway to that. And so to that end, I was prototyping this thing called checklist hunt, which is a topic for another quick talk. But it basically it was a Node.js thingy that needed to use a GitHub token to access some data on GitHub. And I just wanted to throw some stuff on screen. I was just really, at the time, feeling impatient. So I thought, why not use WebSockets? Just send messages back and forth, not worrying about Ajax or anything like that. So out of that came out this module called remote control, because that's kind of what we're building here. It just opens a WebSocket connection from the client to the server. It does a bunch of plumbing, and it maps a server kind of object or a server constructor to a client-side kind of surface, like a stand-in placeholder. It basically creates a tunnel for function calls. So it's like a very simple, basic RPC. It kind of, to get a little deeper into it, there's actually a sort of a README file. I think I have it loaded here. So how does it show? Oh yeah, that's nice. So on the server, we basically have a typical Node module, right? In this case, it's just defining an object with a function called hello world. Very simple, returns the value, right? It does a console log because why not? And then on the client, because we're using Browserify, because it's nice, it's optional, we get that handle to the server object using the special module name. And then we just call it. That's it, right there. Now, because network is asynchronous and JavaScript is, synchronous, it's not that easy, right? Well, what we actually need to do is we need to the return value is wrapped in a promise. So while all this network traffic is happening, this promise is sitting there on the client side, and we can then listen to the promise using the then callback, and we can do whatever we want with it, right? So now, who, by the way, here is who has actually dealt with promises a lot? Okay, so I can just go over promises. Promises are, to me, quite an amazing concept, and I mean, it's not a new concept. It's newish in JavaScript, and definitely, very useful in a lot of cases, because we all know JavaScript. Any Discord network operations, they have to be asynchronous. So we call them, we invoke, and we just pass a callback for when the data is ready. And when we have multiple operations, actually I have a page here from a promise library that explains or has some sample code. So normally we have read file, and we pass a function, right? It's the standard Node.js callback, and we do a bunch of stuff when data returns. Now, when we have multiple operations in sequence, so you read file, then you do something with it, you transform it, call out to some database call, you end up having to keep adding these callbacks, and it creates that callback hell. It's just a bunch of nested things happening, and it's not only hard to read, it's also hard to track variables, it's hard to track state. So the promise is basically like a placeholder for that future value. So that can be, so instead of passing in a callback, it's just returned immediately, and then somebody can attach callbacks to it later. And it allows a bunch of things like chaining, doing some try-catch stuff. It actually kind of is meant to emulate return versus throw. And importantly, even if you call the then function, if you attach a callback after the operation happens, you can still get the value. So it's always guaranteed. It's actually, so it's quite nice and simple that way. Yeah, and then with ECMAScript 7, we're going to get a bunch of interesting features such as async await. And this is something that's very, very popular in C# these days, where instead of doing the then and still having an indent callback, it actually unwraps it and makes it look like just simple synchronous code. It's also quite convenient. So generally what we have here to solve that problem, the client-server link problem, instead of the routes, instead of AJAX, instead of setting up Express, we just use remote control module. It does RPC over WebSocket for just simple function calls. And there's a bunch of grunt work that it also does. It serves up the blank page on the client side, so you don't need to create your HTML file, and does all the wiring up of the actual server placeholder methods on the client, and does all the promise magic. So fairly quick and easy. Now let's talk about displaying the user interface. That's another thing that kind of can be annoying, and there are ways to simplify it and play with it. So for our prototypes, we just want buttons, simple text, you know, click this, you're gonna send a message to Slack, or click this and get some webcam capture. So we don't have, you know, New York Times editorials laying out. We don't have fancy typography. I mean, we want things to look sort of nice, but, you know. And we don't really have scrolling most of the time because not a lot of content is being shown. In fact, if you really were to think extreme, why not use a canvas and just render a bunch of lines and boxes and text, right? It's not so easy because we do need buttons. We need text fields. So there's some interaction complexity that still needs to be handled. And also, Canvas is not for everybody. It's still its own thing to learn. Absolute CSS layouts, however, are actually quite nice, simple, and convenient. So we just define position absolute. We do top left, width, height, or bottom right. And we can even use inline styles because there's only a few elements on screen. So, you know, this is, again, not going into production. So all of these are one-offs, right? Although even with that, the code is going to be kind of verbose, and there's still a bunch of other problems. So to that end, another module that ended up evolving for me is called Boxbits. I was prototyping this HTML5 game. It's actually here. It was kind of supposed to be this. It doesn't really look so great in a small screen, but it's supposed to be this resource management game. And I was also playing around with basic physics to just, you know, have gems bouncing around. But most of this is just divs. All of this is just divs, positioned absolutely, and, you know, animated or placed as they need to be. And out of this kind of came out this chainable jQuery-like API, but not jQuery, to create basic style primitives like images, text, buttons, just boxes. It actually looks kind of like this, right? It just literally creates like a simple screen, looks sort of like a mobile-ish screen, and all of these things, they're just built-in building blocks with some nice fonts that's not Times New Roman to start with. So still uses position absolute. So if you want to inject your own canvas, if you want to inject your own you know, webcam video element or anything else, you just do it. It's because it's using position absolute, so it's an easy thing to play with. And what it also comes with by default is it uses virtual DOM under the hood for reactive rendering. Now, that's a topic that is getting a lot of attention, right? So it's not going to turn into yet another, debating React versus something else kind of conversation. It's a trendy thing. Angular, actually, in its own way, is still somewhat reactive because it uses the digest loop. But let's talk about why this is relevant to us right now in the prototyping, context. UI is genuinely hard to code, right? Because sure, first displaying something is easy. We create DOM elements, we style them, we show them on screen, but then the underlying model, the underlying state, it changes, of course, so we need to update displayed elements, right? And it just starts really accumulating complexity. It's not very easy to maintain, and even for simple hacks, it starts just being annoying to deal with. So it needs to be simplified. And so what a lot of the reactive rendering comes down to really is a very simple idea, is just making all of this work as stateless as possible, right? So if you look at a game engine, from either Unreal or whatever runs Far Cry, you have your 60 frames per second for animation and fluid effects, right? Each frame is just rendered one at a time, right? And then after each frame is done rendering, it's just trashed, and the new one is started, right? Obviously, there's the actual game objects, and that's like the model. It sticks around, but the rest of the pipeline, it's restarted from scratch for the most part. And because it's so easy, because all of these complex effects you can just play with, and they keep rerunning over and over. You don't need to worry about updating state. Now, if you look at DOM, and what shows up on the screen in the browser, your final picture, what you see, is kind of like that frame, right? Obviously, it doesn't run at 60 FPS, but still can update fairly quickly. And then under the hood, you have your JavaScript objects, the actual model that is being displayed onto the screen. And all of the DOM and the styling and the stuff is actually the intermediate steps, right? So wouldn't it be amazing to just ditch it every time you need to display? You draw something, you throw it away, right? So basically rebuild that DOM tree every time, which is kind of how traditional web pages used to work, right? You would just have a template, it would just render, send it to client displays it. If something changes, you refresh the page. That's slow, however, right? So to trash all of that DOM, even if just without the network reload, it's just still quite slow. It still adds up to some lag. Doesn't feel good. So there's a thing called virtual DOM to help with that, right? It started as a concept from React. Now there's actually standalone implementations of it. Again, we're trying to re-render the entire thing from scratch. That's our main source of simplicity, right? And so now what we do, instead of doing all of that stuff with rebuilding the DOM, we rebuild a lightweight blueprint. That's what virtual DOM is. It's really just a set of instructions that correspond to resulting DOM elements. And then the plumbing of, in this case, this NPM module called virtual DOM, which is like a standalone implementation, it manages these blueprints as they keep coming in and matches the real DOM to just match the blueprint. So as your blueprint changes, it'll do the minimal amount of tweaks necessary to make things look that way. It just saves on performance, right? So we get the simplicity of rebuilding the DOM every time from scratch, but we still maintain some of that performance. Now, performance actually in production for virtual DOM can still get a little slow for really large sites, but for us, it's good enough. The other interesting problem that comes up, and this is where a lot of this framework code is stuck, figuring it out, is when to do this redrawing, right? Games are easy. You just do, 60 frames per second, just keeps going, and really heats up the video card. On our typical web front end, we have solutions like observables, we have the digest loop, which basically detect these changes to the underlying model, and that's when you know to re-render something, right? I mean, we could set interval, just run an infinite loop every 10 milliseconds and just repaint. Not going to be great for battery life, right? So why don't we redraw when interesting things happen, right? Which is really incoming events to the code. So this is, it sounds so simplistic that it's almost like, does that really work? Does that make sense? But by definition, things can only change when some input happens, right? And now, input in this case means a lot. So yes, it's mouse clicks. It's moving around stuff in the keyboard and resizing the window. It is also the timer event. It's still kind of like your input as well. AJAX data coming in, WebSocket traffic, as in our RPC. So this is all inputs. So why don't we just re-render the screen when something new happens? In fact, so there's this module that also evolved from that little mini game that basically originally just listened on the document on click, right? Anytime there would be a click, it would say, okay, request animation frame, re-render, right? And it worked really well. When I tried it, I thought, like, that sounds really stupid. Like, how is, but it actually works really well. Now, of course, it doesn't catch, timers does not catch network traffic. To that end, there is a module. It's actually made by the Angular crew. It's called zone.js. And what it does, it's actually kind of amazing how it works. It hijacks literally every possible callback that a browser can have into your JavaScript code and injects little hooks into it. So you can then attach to those hooks and do what you want when the browser enters your JavaScript code. So, and in this case, with this vdom-live node module that came out of this, on these hooks, it just re-renders the screen, right? It's actually very simple and cheap. Great for our prototyping. Don't try this in production. It's probably not going to be good there, but it works here. So overall, then, with Boxbits, they kind of work together. So Boxbits uses virtual DOM to render these pre-styled building blocks, right? And you do this inside this repaint callback, kind of like how in games you have that render function running every 16 milliseconds. So, but in this case, the vdom-live module just optimizes it to only do it when something happens, basically. And it's fast, and again, you saw that resulting output. It looks something like the simple box. The green, the green theme is actually Game Boy inspired. So just to not worry about styling when you don't want to. So, and again, still allows injecting custom webcam displays and all sorts of other interactive bits. And that kind of solves it for the UI, and it's just easy to get back to hacking. I have some code here that is actually something, and it was a demo that I was trying to finish by today, but I kind of ran out of time. But here's basically some of this client-side code. As you can see, it basically says, it just renders a screen. This is the Boxbits API. You just say something, text, at, and these are literally just coordinates, absolute coordinates. And same thing with buttons. There's simple boxes to draw. And notice how there's nesting. So this is what virtual DOM allows you to do, is because you're building it from scratch every time. So you just say, well, I'm creating an element, and I want these children in it, and that's it. It's done, it's sealed, and it's immutable. So you can have your render function is not a sequential list of commands now. It's actually something that returns a fully formed screen, right? Next topic for consideration when prototyping is client-side routing. So that doesn't happen as often as these other concerns, but again, it's the classic single-page app dilemma, right? When you want to have a browser history, but you don't want to refresh the page. So we have the oldest trick in the book is that location hash is the pound sign and then slash something or whatever you want. So if it changes using back and forward keys in the browser, it doesn't refresh the page. It's useful for some prototypes because you want, let's say, a callback, an OAuth callback from a server. As a landing page of some kind, especially if you're publishing it on Heroku, but you still don't want to then change that URL and refresh the page. So there's a module that actually also came out of that, the game prototype. It's called Atomic Routes. And why Atomic? Basically, at the time I looked at React router. Actually, I was working already with the AngularJS router, which there's a so-called Angular UI router, which is actually quite advanced and interesting. It was just way overkill for what I was doing. So it's just basically what came out, just this really quick little hack that we basically set up. You would declare your routes still. You'd say when, slash something, right? So when in the browser bar, it would match that pattern. This object, you would then be able to call a method on it to say, are you active? Okay, you are. Good, right? Are you not active? Okay, you're not. So, and at any point you can call it. So that's why it's atomic. It's simple and it's declarative. And then, of course, it would still be a callback. So if you need to create some DOM, let's say if the callback runs, if a user enters that URL path, you would get this callback. And the one useful thing that I did not see with any other router solutions, what I ended up using is passing a promise to track when the user leaves the route. So basically, the promise would encompass the entire lifetime of that particular browser path. So, and also when it would be hierarchical, then actually that promise wouldn't finish until the user completely leaves the path. So it was actually quite useful. Why? Because with a promise, you can, let's say, user enters a particular path. You want to fire off a network operation. Then the network operation comes back. You want to do something else, do some more rendering. And by that point, the user might have left this route already, right? So you don't want to show stuff on screen. You want to have, it's that race condition when two pieces of the program are racing in time to do something. So a user might have left this URL, but you're still trying to shove some new display elements onto it, onto the page. Because it's a promise, however, and if you wrap the drawing call in that, or the destruction of that user interface in the promise, when you would get the data, you do your stuff, but then immediately it would already be resolved, and you'd immediately get notification that the user left at any point in time. So, and then there's path parameters, and it was just generally convenient with modularity and just being local. So to kind of go over these few topics again, so what we're trying to do is for our Node code, we're trying to use the web browser as a remote interface, right? So for actual interaction between the browser and the server, we use WebSockets as a simple, cheap RPC, and that's where that remote control module is useful. Then for displaying the user interface, we can just really skip CSS and just use inline styles or the Boxbits, element builder, and use virtual DOM with refresh on event. That's kind of like the approach. To just re-render the screen anytime you need to with quick results. And then if you want client-side routing, there's atomic routes, which here's actually some sample code also here. So we declare these routes this way. So root is just root. Then we say when. And then you get this handle that you can always interrogate and say, is it active or not? So when we render, we literally say, is this route active? OK, render that screen. Otherwise, render something else, right? So just quick and convenient. So and the general, so that's the atomic routes module. That's where the acronym comes from. BARC is Boxbits, atomic routes, remote control. And as you can see, all of these things are kind of using concepts that are not obvious, I guess, in the production world. If you're just building a website, using WebSockets to drive all of your traffic back and forth is not your immediate first thought that comes to mind. Using pure inline styles, again, not a very common concept, but quite okay here, right? So it's all about forgetting that convention and just hacking the quickest thing you can, right? And I guess that kind of wraps it up for me. Again, I'm on Framework on Twitter and GitHub, and we are hiring at MyPlanet. So, and here's some links. I attached this to the EventMobi page. So here's some links to the GitHub modules to see how they work. I will eventually put up the demo code as well online. So, and at this stage, if anybody has any questions,